Hello everyone. Today we'll discuss about logarithmic amplifier. So what is logarithmic amplifier? Logarithmic amplifier means a amplifier. If we give input V in, then the output will be k factor multiplied by logarithmic of V in, and base may be 10 or E. It can be varied. Okay. So this is called logarithmic amplifier. So for this purpose, we have a circuit. So firstly, we need to draw this circuit. Here, this circuit. Here is resistance R. There is an op-amp, and in the feedback path there is a diode. And this is our input voltage V in, and the non-inverting input is grounded. Okay. So here is our output V output. So we have to find out the expression of the circuit, whether it is logarithmic or not. Okay. So we know that the current flow through this diode is ID. So ID. So we may say that the current is flowing through R1, and the same current is flowing through diode D is ID. So here I and ID is same. So I equal ID. Two currents are same, as the no input is entering through the inverting input. So the expression of I will be V input minus 0 by resistance R. Why 0? Because we know that the voltage here and here is same. So as the non-inverting input is grounded, it is grounded. So the voltage here will also be 0. And ID, and what will be the value of ID? ID will be Is exponential power Vd by Vt. So here we may find that V input by resistance R equal Is exponential Vd by Vt. Okay. So we need to find out the expression respect of V output. So here we know that the output voltage will be find out by making a loop here Vd. So if I make a loop here, then I will find out that V output is equal minus Vd, minus Vd. So I will use this condition to find out the V output. So V in by R equal Is. Okay, sorry. So we may write now the Vd by Vt equal V input by Is multiplied by R. Okay. So if we want to remove this exponentially, then obviously we have to do logarithmic both sides. So if I apply this logarithmic log 10 log E Vt by Vt equal log E V input Is multiplied by R. So we know that the base this will be removed. So here Vd by Vt equal ln V input by is into r. So finally, if I apply this Vd equal minus V output, then I will find out that V output equal minus Vt ln V in by is r. P in by INS. So this is the ultimate expression of logarithmic amplifier. So this is the ultimate expression of logarithmic amplifier. Okay. Here this is amplifier. Why? Because if I give input V in, here is the output is okay log E V in. So this and this both are same expression. That's why this is our logarithmic amplifier. Okay. Now we will discuss about anti-logarithmic amplifier. Anti-logarithmic amplifier. So in this case, the circuit is almost same, but the difference is the direction of diode. So the circuit is almost the before one. Here op-amp, but the difference is there. The diode is now connected in reverse direction. Okay. And here V input and the non-inverting input is grounded. That's why the voltage here also will be 0. Resistance R and the voltage VD here plus minus, and here V output. Okay, now we will apply the same condition. The current is flowing. The current is flowing here. Oh, sorry, there is a mistake. Sorry, there is a mistake. So in this case, diode will be in that path, and the feedback path will be with a resistance R. Resistance R. Here the diode D. So in this case also we may say that the current is flowing through diode D, ID will be the same current flowing through R. So here also will be I. So in this case we may say that ID is equal to I. Okay. So what is the value of ID? ID is before I is exponential VD by VT, and the current I is 0 minus V output by R. Okay. Okay, so here we may write V output by R is equal is exponential VT minus by VT. So ultimately V out is equal minus R into is exponential VD by VT. So the expression is consist of V output and VD, but we have to find out the expression of V output and V input. If the V output is anti-log of V input, then that will be called anti-logarithmic amplifier. So for this reason, if I make a loop here and here voltage VD and the voltage here VD here plus and minus, then we'll easily find out that V input here is equal to VD. V input is equal to VD. So we have to apply the voltage V input instead of VD. So here V output equal minus Is R exponential V input by Vt. So this is the final expression of our anti-logarithmic amplifier. Here we may say that the anti-log or anti-log is equal to anti-log is equal E. Okay, so here E, here V in and here V output. So it is clearly a anti-logarithmic amplifier. Anti-log amplifier. Okay. So for example, we have to find out if the input voltage is here V. This is our input. So if a question is given to find out, we don't know what is the expression of amplifier. We have to find out a power 1 by 5. So what do you do before getting the value of a power 1 by 5? So in this case, it's pretty easy to find out. So here a input, or you will use a logarithmic amplifier. So log, our output will be what? Log a, and we just need to multiply 1 by 5 factor with input. So the output will be 1 by 5 log a. Okay, so if I use anti-log amplifier now, anti-log here, anti-log, then the output will be a power 1 by 5. Clear? Okay, why? Because it may be right now in that way, log a power 5. Now what does it do? Anti-log amplifier will cancel out this log. Okay, it will cancel out this log, so the only remaining part will be 1 by power 1 by 5, a by power 1 by 5. So find out in various cases whether the output will be given a power cube or a power something x. So we may easily find in this way. So this is our finally amplifier circuits. Okay, so these are the circuits of logarithmic and anti-logarithmic amplifier. Hope that you guys understand well. So thank you everyone.